When we start learning about vectors, we often borrow the ideas from physics. That is, in our physical world, there is a point, and we are looking at a line from a reference point to that point, and then that line is called a vector, and it's directed towards that point. In physics, we say that we are living in a three-dimensional world, and then the fourth dimension is time. But when we do higher mathematics, we often come across vectors that are more than four-dimensional, that are often 50, 100, 2000 dimensional vectors. The thing here that you should not confuse with is that the dimension in which a vector space is living in mathematically is not really the physical dimension that we are taught in physics. A dimension in mathematics is nothing but how many points do we have in a vector. And then a vector is nothing but collection of points. So in mathematics, there is practically no limit on how many points you can have in a vector. The key thing, however, is that anything that we have learned and we have intuition for from our physical world, from our working in a physical world, vectors works in these higher dimensions. So we can still have angle between vectors, we can still have cosine similarity, we can still have length of a vector in these higher 10,000, 20,000 dimensions, although we can't really visualize how they would look like.